Right now, you are not standing still, not even for a fraction of a second. You might feel motionless, but Earth is racing through space at incredible speed, spinning, orbiting, and being pulled through the galaxy by forces so massive they're almost impossible to imagine. And the deeper truth is even more unsettling. We are not just moving around the sun. The entire solar system is traveling through the Milky Way, and the Milky Way itself is drifting through the universe in a direction scientists are still trying to fully understand. There is no fixed rest point in space, no universal ground, no true stillness. Everything, Earth, the sun, the stars you see at night, is in constant motion towards something we cannot directly see or fully explain. So the question becomes unavoidable. If everything is moving, if nothing is truly still, one of the most difficult ideas to fully grasp about reality is this simple truth: nothing in the universe is truly still. At first, this might sound strange, because from our everyday experience, it feels like we are standing on solid ground. We sit in a room, we look outside, and everything appears stable. A building does not seem to move. A tree stands in one place, and even the ground beneath your feet feels completely fixed. But this sense of stillness is only an illusion created by our limited perspective. In reality, everything around us is in constant motion, whether we notice it or not. Earth itself is not a stationary object. It is constantly spinning around its axis, completing a full rotation every 24 hours. While you are reading this, you are already moving at hundreds of kilometers per hour without feeling anything at all. At the same time, Earth is also orbiting the Sun at an incredible speed of about 107,000 kilometers per hour. This means that even if you think you are standing still in one place, you are actually traveling through space at a speed far greater than anything we experience in everyday life. There is no pause, no stop, and no moment where the planet truly rests. But the movement does not stop there. Our entire solar system is also in motion. The Sun, along with all the planets that orbit it, is moving through the Milky Way galaxy. It follows a massive orbital path around the galactic center, taking hundreds of millions of years to complete just one full revolution. This means Earth is not only moving around the Sun, but is also being carried along by the Sun itself as it travels through space. Everything within our solar system is part of this larger journey, moving together like passengers on a vast, invisible ship. Even the Milky Way galaxy, which contains billions of stars including our Sun, is not fixed in place. It is slowly drifting through the universe, influenced by gravitational forces from other galaxies and massive cosmic structures. It does not sit still in one location. Instead, it is part of a much larger cosmic environment where everything is in motion relative to everything else. Galaxies move, clusters of galaxies move, and even the large-scale structure of the universe is evolving and changing over time. What makes this even more fascinating is that there is no universal reference point where everything stops. There is no center of space where the universe can be measured from a place of rest. Every motion we observe is relative to something else that is also moving. This means that the concept of being at rest does not truly exist in a physical sense. Rest is only something we define based on our immediate surroundings, not an absolute condition of the universe. Every single object in existence is part of a larger chain of movement. Earth moves around the Sun moves through the galaxy moves through the universe, and the universe itself is expanding. Nothing breaks this chain, nothing escapes it. Even the light from distant stars is traveling through expanding space, constantly being affected by the motion of the cosmos. So when we say there is no true stillness in the universe, it means that everything, from the smallest planet to the largest galaxy, is always in motion. The idea of complete rest simply does not exist on a cosmic scale. What we experience as stillness is only a temporary and local situation, not a fundamental truth of reality. The universe is never frozen, never paused, and never unchanged. It is always moving, always shifting, and always evolving in ways far beyond what we can feel in our daily lives. One of the most surprising facts about our existence is that Earth is moving through space at a speed so high that it would be hard to believe if we could feel it directly. Yet we don't feel it at all. There is no shaking, no wind of motion, no sense of rushing through the universe. Everything feels calm and stable. But beneath that calm experience, our planet is in constant high-speed travel, carrying every ocean, mountain, city, and living being along with it. Earth is not stationary in space. It is continuously moving in multiple directions at the same time. First, it spins around its own axis. This rotation is what creates day and night. Even though it feels gentle from our perspective, the surface of the planet near the equator is actually moving at roughly 1,600 km per hour due to this spin. That means every point on Earth is constantly shifting position, even when we are sitting still. Earth is also orbiting the Sun. This motion is far more dramatic in scale. Our planet follows a long, curved path around the Sun, completing one full orbit every year. While it does this, it travels at an average speed of about 107,000 kilometers per hour. This is not a slow drift or a minor movement. It is an extremely fast journey through space. If we could somehow detach Earth from its invisible path and observe it from outside the solar system, we would see a planet racing through space like a moving object with no pause button. But even this is only part of the picture. Earth's motion is not separate from the Sun. We are not travelling alone. The entire Earth is being carried by the Sun itself as it moves through the Milky Way galaxy. So while we orbit the Sun, we are also being pulled along by the Sun's own motion. This creates a combined movement that is far more complex than a simple circular path. It is more like being inside a moving system that is itself travelling through another larger moving system. What makes this reality even more difficult to imagine is that this motion is completely silent and invisible to us. We do not feel acceleration because everything around us is moving together at the same speed. The air, the ground, the buildings, and even our bodies are all part of the same motion. There is no contrast that would normally allow us to sense speed. In everyday life, we only feel movement when something changes suddenly or when we are compared to something still. But in space, there is nothing truly still nearby to compare against. This is why Earth's speed feels unreal. It is not because the speed is small, but because the system we are inside of hides it completely from our senses. We are like passengers inside a vehicle that never shakes, never stops, and never gives any signal that it is moving. Only scientific observation reveals the truth that we are constantly travelling through space at incredible velocity. And this motion is not slowing down. There is no natural breaking point in space that stops Earth or holds it in place. Instead, we continue along a stable orbital path, shaped by gravity and the structure of the solar system. This path has existed for billions of years, and will continue as long as the same forces remain in balance. So when we say Earth is travelling at impossible speed, it is not just about numbers. It is about the gap between what we feel and what is actually happening. Our senses tell us we are still, but reality tells a completely different story. Every second, we are covering enormous distances through space without even realising it. When most people think about Earth's motion in space, they usually imagine a simple picture, the Earth going around the Sun once every year. This idea is correct, but it is only a small part of a much larger and more complex journey. The Earth is not moving in isolation, and it is not only tied to the Sun. Instead, we are part of a much bigger structure that extends far beyond our solar system. and that structure itself is also in motion. To understand this properly, we need to step away from the idea that the Sun is a fixed center of everything. The Sun is not a stationary anchor in space. It is a star among hundreds of billions of stars inside a massive galaxy called the Milky Way. And just like Earth orbits the Sun itself is also moving around the center of this galaxy. This means that Earth's path is not just a simple circle around the Sun, but part of a much larger spiral-like journey through space. The Sun, along with all the planets in our solar system, is traveling around the center of the Milky Way galaxy at an enormous scale. This motion is not quick in human terms. It takes roughly 225 to 250 million years for the Sun to complete one full orbit around the galaxy. This period is so long that no human civilization has ever witnessed even a fraction of a complete galactic orbit. While we measure years and decades, this motion operates on a time scale that stretches across geological eras. As the Sun moves, it carries the entire solar system with it. Earth is not left behind or moving separately from this journey. Instead, our planet is locked into the Sun's gravitational system, meaning that every movement of the Sun becomes part of Earth's own path. So while Earth orbits the Sun once every year, both Earth and the Sun are simultaneously traveling through the galaxy together. This creates a layered motion. Earth circles the Sun, and the Sun carries Earth through a much larger orbital path around the galaxy. The shape of this movement is not a perfect circle. It is more like a long, curved spiral path through space. As the solar system travels, it moves through different regions of the Milky Way, passing through areas with varying densities of stars, gas clouds, and gravitational influences. This journey is not static or repetitive in a simple sense. It is dynamic, constantly shifting, as the solar system responds to the gravitational structure of the galaxy. What makes this even more interesting is that we do not feel any of this movement. From our perspective on Earth, there is no sensation of being carried through the galaxy. The reason is that everything in our local environment is moving together as one system. The Earth, the Sun, the Moon, and everything within the solar system share the same overall motion. Because there is no external fixed reference point nearby, our senses cannot detect this vast journey. The idea that we are only orbiting the Sun gives a very limited view of reality. It hides the fact that we are part of a much larger cosmic structure that is constantly in motion. The solar system is not a closed, isolated unit sitting still in space. It is an active participant in the movement of the galaxy itself. Every planet, every asteroid, and every particle within our system is being carried along this galactic path. And even this is not the final layer of motion. The Milky Way galaxy itself is also moving through space, influenced by other galaxies and large-scale cosmic forces. But within this third layer of understanding, we begin to realize something important. Earth's journey is not simple or local. It is part of a nested system of motion, where smaller movements exist inside larger movements, and nothing remains fixed at any level. So when we say Earth is orbiting the Sun, we are only describing one part of a much bigger reality. In truth, we are traveling through the galaxy as part of a vast system that is itself in motion, carrying everything we know along with it through space on a path that is far larger than human perception can easily imagine. When we think about motion in space, we often focus only on individual planets or the Sun itself. But the reality becomes much deeper when we step back and look at the solar system as a single, connected structure. The Sun, the planets, moons, asteroids, and everything bound by its gravity are not moving separately in different directions. They form one unified system, and that entire system is traveling together through space on its own long and continuous path. The solar system is not fixed in place inside the Milky Way. It is constantly moving, carried by the gravitational dynamics of the galaxy. Instead of staying in one region, it drifts through space in a large orbital route around the galactic center. This movement is not random. It follows a structured path shaped by the combined gravitational pull of the galaxy's mass, including stars, dark matter, and massive interstellar structures that surround it. To understand this motion, imagine the solar system not as a collection of separate objects, but as a single ship moving through a vast cosmic ocean. The Sun acts like the central body holding everything together, while each planet remains bound to it through gravity. But this entire ship is not anchored anywhere. It is traveling through the Milky Way, continuously changing position relative to other stars and regions of space. This journey is extremely large in scale. The solar system moves at a speed of roughly 800,000 kilometers per hour around the center of the galaxy. Despite this enormous velocity, the movement feels completely invisible to us because everything within the system shares the same motion. There is no external frame of reference nearby that remains still, so we cannot directly sense the drift. All planets, including Earth, are carried along together, maintaining their relative positions while the entire structure moves through space. What makes this even more fascinating is that the solar system does not travel through an empty environment. Space is not truly empty. It contains gas clouds, cosmic dust, radiation fields, and gravitational influences from nearby stars and star clusters. As the solar system moves through these regions, it experiences subtle changes in its environment. These changes do not stop its motion, but they shape its long-term path through the galaxy. The path itself is not a perfect straight line or a simple circle. It is more like a curved and shifting trajectory, influenced by the uneven distribution of mass within the Milky Way. The galaxy is not uniform. It has spiral arms, dense star regions, and vast empty gaps. As the solar system moves, it passes through these different zones, adjusting its path slightly over time due to gravitational interactions. This creates a long, slow, and complex journey that unfolds over hundreds of millions of years. Even though we cannot feel this movement, it is continuously happening. Every second, the solar system is changing its position relative to distant stars. If we could mark its position in space over long periods of time, we would see a smooth but persistent drift, like a slow-moving vessel crossing an enormous ocean without visible landmarks. This is why the idea of the solar system being distant stationary is completely incorrect. There is no fixed location where it rests. It is always in motion, always advancing along its galactic route. And because Earth is part of this system, we are also part of this same journey. Every rotation of the Sun, every orbit of the planets, and every moment of human life is happening inside a moving structure that never stops. So when we say the solar system has its own path, it means that we are not just orbiting within a small local system. We are inside a larger travelling structure that is continuously moving through the galaxy. It is a journey without pauses, without anchors, and without a final fixed point in space. When we zoom out even further from the solar system, a much larger structure comes into view, the Milky Way galaxy. This is the vast collection of hundreds of billions of stars, along with planets, gas clouds, dust, and dark matter, all held together by gravity. From our perspective inside it, the Milky Way often feels like the entire universe because it contains everything we can see in the night sky. But in reality, even this enormous structure is not fixed in place. It is not a stationary island in space. It is moving. The Milky Way is travelling through the universe as part of a much larger cosmic environment made up of many galaxies. These galaxies are not isolated or motionless. They interact with each other through gravity, pulling and influencing one another across vast distances. Because of these interactions, the Milky Way is slowly drifting through space, changing its position relative to other galaxies over extremely long periods of time. This movement is not something that happens quickly or in a way we can observe in real time. It unfolds across billions of years, but even though it is slow, it is continuous. The Milky Way does not stay in one location. It follows a long trajectory influenced by the gravitational pull of nearby galaxies, including large structures like the Andromeda Galaxy and the surrounding galaxy groups that form our local region of the universe. One of the most important ideas to understand here is that space on this scale is not empty and uniform. It is shaped by massive structures that contain galaxies grouped together in clusters and filaments. These structures form a kind of cosmic web where galaxies are connected through gravity and motion. The Milky Way is part of this web, and like everything else in it, it is being gently pulled and guided along a path defined by the distribution of mass across the universe. Because of this, the Milky Way's movement is not a simple straight line. It is more like a slow drift, influenced by multiple gravitational forces at the same time. Nearby galaxies pull on it, large galaxy clusters affect its direction, and the overall expansion of the universe also plays a role in shaping how it moves. This creates a complex and evolving path rather than a fixed route. Even though the Milky Way is moving, we do not feel this motion at all from inside it. This is because everything within the galaxy is part of the same system. The Sun, Earth, and all other stars in our galaxy are bound together by the galaxy's gravity. Since we are all moving along with the Milky Way, there is no internal signal that reveals this motion to us. It is similar to being inside a massive structure that is floating through space without any external reference point nearby to compare against. If we could observe the Milky Way from a truly external position over billions of years, we would see it shifting across the cosmic background, slowly changing its position among other galaxies. It would not appear frozen or permanent. Instead, it would behave like a large moving structure participating in the ongoing evolution of the universe. Another important aspect of this motion is that the Milky Way itself is also changing in shape while it moves. It is not a rigid object. It has spiral arms that rotate, regions where new stars are forming, and areas where old stars are gradually fading. As it travels, it continues to evolve internally, meaning its structure and its position are both in motion at the same time. In the distant future, the Milky Way is expected to interact closely with other nearby galaxies due to gravitational attraction. These interactions are part of the natural evolution of galaxy motion. But even without focusing on future events, the key idea remains clear. The Milky Way is not still, not fixed, and not isolated. So when we say our galaxy is moving through the universe, it means that everything we know, every star we see in the night sky, every system within it, and every planet like Earth, is part of a massive structure that is itself travelling through space. It is a motion so large in scale and so slow in perception that it escapes human awareness, yet it defines the true nature of our place in the cosmos. One of the most important but least intuitive realities about the universe is that motion is not random. Even though space looks empty to the naked eye, it is filled with influences that shape how everything moves. We often imagine space as a silent void where objects drift freely in straight lines, but in reality, nothing travels without being affected by something else. Every direction, every curve, and every long-term path is shaped by forces that we cannot see, but whose effects are constantly acting on everything, including our own galaxy and solar system. The most powerful of these influences is gravity, but not just the gravity we experience on Earth. What we are dealing with on a cosmic level is something far larger and more complex. Gravity is not limited to planets pulling on objects or the Sun holding Earth in orbit. On the scale of galaxies and the universe, gravity becomes a force that stretches across enormous distances, connecting massive structures that are separated by millions or even billions of light years. There are enormous regions in space filled with clusters of galaxies, superclusters, and vast structures made of both visible matter and dark matter. These are not isolated points floating independently. They form a kind of hidden framework in the universe, where mass is unevenly distributed. Some regions contain huge concentrations of matter, while others are relatively empty. This uneven distribution creates gravitational differences that influence how everything moves through space over time. Because of this, our galaxy and everything within it are constantly being affected by gravitational pulls from large structures we cannot directly see or fully map in real time. These forces do not act like sudden pushes or sharp turns. Instead, they work slowly and continuously, shaping long-term motion in subtle but powerful ways. Over millions and billions of years, these influences determine the direction in which galaxies drift, cluster, or separate from one another. Even though we cannot see these structures directly with our eyes, we can detect their presence through their effects. For example, when astronomers observe the motion of galaxies, they notice that galaxies are not moving randomly. Instead, they tend to flow towards certain regions of space where there is a higher concentration of mass. This suggests that something unseen is guiding their motion, acting like a large-scale gravitational map that structures the movement of everything in the universe. One of the most fascinating parts of this idea is that much of what influences cosmic motion is invisible. A significant portion of the universe is made up of dark matter, a form of matter that does not emit light or interact with electromagnetic radiation in the way normal matter does. We cannot see it directly, yet its gravitational effects are essential in holding galaxies together and influencing how they move. Without it, the structure and motion of galaxies would be completely different. This means that when we talk about being pulled by invisible forces, we are referring to a combination of both visible and invisible influences that shape cosmic direction. It is not just stars and galaxies we can observe, but also hidden mass that forms an unseen structure beneath everything we can detect. This hidden structure acts like its guide, shaping the paths of galaxies over time. These forces are completely unnoticed in daily life. We do not feel them because they operate on scales far beyond human experience. The gravitational influence of distant galaxy clusters does not create sudden changes in our environment. Instead, it works over extremely long periods, slowly affecting the motion of entire galaxies, including our own Milky Way. Because we are inside this system, moving along with it, we do not perceive the subtle changes in direction caused by these forces. To understand this better, imagine being inside a massive river that is so large you cannot see its edges. The water is not flowing in a perfectly straight line. Instead, it bends and shifts depending on the shape of the riverbed beneath it. You would not feel each small change in direction, but over time, you would notice that your path is influenced by something hidden beneath the surface. In a similar way, galaxies move through space shaped by a gravitational landscape that we cannot directly see. These invisible forces also help explain why the universe has structure instead of being completely uniform. Without them, matter would not clump together into galaxies, stars would not form in the same way, and cosmic motion would lack direction. The universe would look very different. Instead, gravity from both visible and invisible sources organizes matter into patterns, filaments, and clusters that stretch across vast distances. So when we say we are being pulled by invisible forces, it is not a poetic idea. It is a literal description of how motion in the universe works. Every large-scale movement from galaxies drifting through space to the formation of cosmic structures, is influenced by forces that cannot be seen directly, but can be measured through their effects. We are part of this system as well, carried along by the same invisible structure that guides everything else in the universe. One of the most surprising ideas in modern cosmology is that the universe does not have a single center. In our everyday thinking, we are used to the idea that every system has a central point. A circle has a center. A city has a center. Even our solar system feels like it has a center because the sun sits in the middle and planets orbit around it. This kind of thinking comes naturally to us because we experience structured systems all the time. But when we try to apply the same idea to the universe as a whole, it stops working. The universe does not behave like a simple object with an edge and a middle. Instead, it is expanding everywhere at once. This means that galaxies are not flying outward from a single point in space. Rather, space itself is stretching between them. From any galaxy in the universe, it would appear as if everything else is moving away in all directions. This creates the illusion that that galaxy is at the center, even though it is not. In reality, every point in the universe experiences the same effect. To understand this, imagine the surface of a balloon being slowly inflated. If you place small dots on the surface and then expand the balloon, each dot moves away from every other dot. None of the dots can claim to be the center because the expansion is happening across the entire surface at the same time. There is no special point on the surface where the expansion begins. Every point behaves as if it is in the middle from its own perspective. The universe behaves in a similar way, but in 3 dimensions instead of 2. Because of this structure, the idea of a universal center becomes meaningless. If you travel in any direction in space, you will not eventually reach a central location where everything originates. Instead, you will continue moving through expanding space, observing galaxies shifting away as distances between them increase. No matter where you go, the large-scale structure of the universe will look broadly similar, with galaxies distributed across vast regions and no single focal point. This concept also changes how we think about motion. In a universe with a center, you could define movement as being relative to that central point. But in a universe without a center, motion is only defined relative to other objects. There is no fixed reference frame that everything can be measured against. This is why astronomers describe motion in terms of relative velocities rather than absolute position in space. Even the idea of outward direction becomes unclear on a cosmic scale. We often imagine the universe expanding into empty space, but this is not what is actually happening. There is no outside region that the universe is expanding into. Instead, space itself is growing internally. The distances between galaxies increase because the fabric of space is stretching, not because galaxies are moving away from a central explosion point. This means that if you were placed in any galaxy, including the Milky Way, you would observe the same pattern. Distant galaxies would appear to be moving away from you in all directions, giving the impression that you are at the center of expansion. But if you moved to another galaxy, the same observation would occur again. This symmetry is a key feature of the universe on large scales. No location is more central than another. Another important consequence of this is that the universe does not have an edge either. If there is no center, there is also no boundary from which everything expands outward. The universe does not have a wall or outer limit that it is growing toward. Instead, it is the distances within space that are changing, not space moving into something else. This idea can be difficult to visualize because our minds are used to objects with clear shapes and boundaries. We naturally look for starting points and endpoints. But on the largest scale we can observe, the universe does not provide these features. It is a continuous structure where every region follows the same physical rules and no location holds a special central position. So when we say there is no center of the universe, it means that space is not organized around a single point of origin. Instead, every part of the universe participates equally in its expansion and motion. This removes the need for a central reference and replaces it with a more complex and interconnected view of reality, where position is always relative and every observer experiences the universe in a similar way from their own location. When we think about direction in everyday life, everything feels very clear and fixed. We say something is up or down, left or right, forward or backward. These directions feel natural because they are based on our experience on Earth, where gravity always pulls us toward the ground and gives us a stable reference point. Because of this, our minds assume that direction is something universal and the same everywhere. But when we step outside Earth and look at the universe on a larger scale, this idea completely breaks down. There is no universal up or down. There is no cosmic floor that everything stands on, and no ceiling above everything else. Direction only makes sense when it is measured relative to something else nearby. For example, on Earth, down means toward the center of the planet because gravity pulls everything inward. But if you are floating in deep space far away from any planet or star, there is no natural sense of down at all. You could rotate in any direction and still have no fixed orientation that feels correct or incorrect. This becomes even more complex when we think about motion across the universe. Galaxies, stars, and planets are all moving in different directions at the same time. There is no single direction that can be called the correct or true direction of the universe. What looks like forward motion from one point may look like sideways or even backward motion from another point. Everything depends on the observer's position and what they are comparing it to. Because of this, space does not have a built-in coordinate system that applies everywhere. In daily life, we use directions based on Earth's surface or the position of the sun, but these are local systems. They only work because we are inside a stable gravitational environment. Once we move beyond that environment, those references lose their meaning. In deep space, astronauts must rely on artificial reference points, such as spacecraft orientation or distant stars, because there is no natural sense of direction. Even the movement of galaxies shows this lack of absolute direction. A galaxy moving in one direction relative to another galaxy does not mean it is moving in a universal sense. Another observer in a different galaxy would describe the motion differently. This is because motion in the universe is always relative, not absolute. There is no single fixed framework that defines all movement from a universal perspective. Another important idea is that the universe itself does not have a preferred orientation. It does not rotate around a top or bottom, nor does it expand in a single outward direction. Expansion happens everywhere at once, meaning that every region of space experiences the same effect regardless of orientation. This removes the idea that the universe has a forward direction of growth or a specific axis that defines how everything moves. This also affects how we understand navigation on a cosmic scale. If we imagine traveling through space, there is no natural straight line that is universally straight. What appears straight in one frame of reference may appear curved in another. This is because space and motion are influenced by gravity and the structure of space-time itself, which can bend paths and change how directions are perceived. So when we say direction in space is not absolute, it means that the universe does not provide a single fixed system of orientation that applies everywhere. All directions depend on perspective, location, and relative motion. What feels like a clear sense of which way is which on Earth disappears completely when we step into the larger structure of the cosmos. When we try to understand our place in the universe, it is easy to think of Earth, the solar system, and even our galaxy as separate structures moving independently. But on a deeper level, everything is connected through motion. Nothing exists in isolation. Instead, all large structures in the universe are part of a continuous flow, where matter is always shifting, drifting, and being carried along by cosmic forces over vast periods of time. This idea of a cosmic flow means that the universe is not made up of static objects sitting in fixed positions. Instead, it behaves more like a constantly moving system where everything is linked through gravity, expansion, and large-scale motion. Galaxies are not randomly scattered and frozen in place. They are part of a network of movement where each structure influences and is influenced by others across immense distances. Our galaxy, the Milky Way, is one part of this larger flow. It does not move alone or independently. It interacts gravitationally with nearby galaxies, galaxy clusters, and the vast structure of the universe itself. These interactions create a kind of slow, continuous drift where galaxies are gently guided along paths shaped by the distribution of matter across space. This is not a sudden or chaotic movement, but a long and steady process that unfolds over billions of years. What makes this concept important is that it removes the idea of isolated motion. There is no single object in the universe that moves completely on its own, without being influenced by something else. Every motion is part of a larger chain. A planet moves around a star moves within a galaxy moves within a cluster, and clusters themselves are part of even larger cosmic structures. Each level of the universe is connected to the next through continuous movement. This flow is not only about motion through space, but also about the way space itself behaves. The universe is expanding, which means the distances between large structures are increasing over time. This expansion is not like objects moving through empty space. It is space itself stretching and carrying galaxies along with it. Because of this, the motion we observe is not just objects moving through a static environment, but a combination of objects moving and space changing at the same time. This cosmic flow is completely invisible. We do not feel it, and we do not see it directly. This is because everything around us shares the same general motion. We are embedded inside the flow, not observing it from outside. Just like a leaf floating in a river cannot easily detect the full movement of the water it is carried by, we cannot easily perceive the large-scale movement of the universe we are part of. Even though this flow is invisible to us, its effects are everywhere. The arrangement of galaxies, the formation of cosmic structures, and the large-scale patterns of the universe all show signs of continuous motion. Nothing remains fixed in one configuration forever. Over time, everything shifts position, slowly reshaping the structure of the cosmos. So when we say we are part of a larger cosmic flow, it means that our existence is not separate from the movement of the universe. We are not standing outside, observing motion happening elsewhere. Instead, we are inside that motion, carried along with everything else, as part of a universe that is always in motion, always evolving, and always connected through vast and continuous movement. One of the most important discoveries in modern astronomy is that the universe is not static. It is not fixed in size, and it is not staying the same from one moment to the next. Instead, the universe is expanding, and this expansion is happening everywhere at the same time. This means that the structure of space itself is changing, and the distances between large cosmic objects are gradually increasing over time. To understand this properly, it is important to move away from the idea that galaxies are simply flying outward into empty space. That is not what is happening. There is no central explosion point, where everything began spreading outward from a single location. Instead, space itself is stretching, and this stretching causes galaxies to move farther apart from each other, even if they are not actively pushing away. Imagine space as something that can grow or stretch like a flexible fabric. When this fabric expands, every point on it moves away from every other point. The important detail is that no single point is the center of this expansion. Every region experiences the same effect. This is why galaxies do not need to be traveling through space, in the traditional sense, to appear as if they are moving away from one another. The space between them is increasing, which creates the same result. This expansion is not directly visible in our daily experience. On small scales, such as within solar systems or galaxies, gravity is strong enough to hold structures together. That is why Earth does not drift away from the Sun due to cosmic expansion. The same is true for stars within a galaxy. They remain bound together despite the universe expanding on larger scales. The effects of expansion become more noticeable only when we look at extremely large distances between galaxies. When astronomers observe distant galaxies, they notice a consistent pattern. The farther away a galaxy is, the faster it appears to be moving away from us. This observation is not because we are at a special location in the universe, but because space itself is expanding uniformly. Any observer in any galaxy would see a similar pattern from their own position. This reinforces the idea that expansion is not centered around one point, but is a property of space everywhere. Another important aspect of this expansion is that it is continuous. It is not something that happened only in the past. It is still happening right now, at this very moment. As time passes, the distances between unbound cosmic structures continue to increase. Galaxies that are not gravitationally connected slowly drift farther apart as space stretches between them. Over extremely long timescales, this changes the large-scale structure of the universe. Even though this process is happening everywhere, we do not feel it in our everyday lives. This is because the scale of expansion is extremely large compared to the size of atoms, planets, and even galaxies. Local forces like gravity and electromagnetic interactions dominate at small scales, keeping objects stable and preventing them from being stretched apart. As a result, expansion becomes meaningful only when we observe the universe on the largest possible scales. The idea that the universe is expanding around us also changes how we think about distance and time. Light from distant galaxies takes billions of years to reach us, and during that time, the universe continues to expand. This means that the light we see today comes from a version of the universe that no longer exists in the same form. The galaxies we observe have already moved farther away, and the space between them has grown larger since that light began its journey. So when we say the universe is expanding around us, it means that space itself is dynamic. It is not a fixed stage where events happen, but an active structure that changes over time. Every region of space participates in this expansion, shaping the large-scale evolution of the cosmos and continuously redefining the distances between everything that exists. One of the most unsettling ideas in modern cosmology is that, even with all the knowledge we have today, there are still limits to what we can understand about the ultimate direction of the universe. We can measure speeds, map galaxies, and observe the expansion of space, but when it comes to the deepest question, where everything is ultimately heading, there is still no complete answer. This is because the universe is not a simple system with a clearly defined path or endpoint. It is an evolving structure influenced by many different forces at once. Gravity pulls matter together, dark energy drives expansion, and large-scale structures shape the movement of galaxies across enormous distances. All of these factors interact in complex ways that unfold over billions of years. Because of this complexity, predicting a single final direction becomes extremely difficult. When we talk about direction on Earth, things are straightforward. We can say something is moving north, south, east, or west, and those directions remain consistent. But on a cosmic scale, there is no fixed reference system that defines a universal direction for everything. Every galaxy has its own motion relative to others, and those motions are influenced by local and large-scale gravitational effects. This means that what looks like a clear path from one perspective may look completely different from another. Another challenge is the scale of time involved. The processes that shape cosmic motion happen over billions of years. Changes that define the universe's structure are so slow that they are nearly impossible to observe directly within a human lifetime. Because of this, we can only see snapshots of a much larger process. We observe galaxies at different distances, which also means we are seeing them at different points in the past. This makes it even harder to determine a single unified direction for everything. There is also the influence of unknown elements in the universe. A large portion of cosmic behavior is affected by dark matter and dark energy, which we cannot directly observe in the traditional sense. We only know they exist because of the effects they produce. Dark matter shapes the structure of galaxies and clusters, while dark energy drives the accelerated expansion of the universe. But since we do not fully understand their nature, we cannot precisely predict how they will influence the universe's long-term evolution. Because of these uncertainties, scientists can model possible futures of the universe, but they cannot confirm a single final outcome with complete certainty. There are different scenarios based on how forces like dark energy behave over time. The universe might continue expanding forever, it might slow down in certain regions, or it might evolve in ways that are still not fully understood. Each possibility depends on variables that are still being studied. We are also limited by observation. We can only see a portion of the cosmos, the observable universe. Beyond that boundary, light has not had enough time to reach us since the beginning of cosmic expansion. This means there may be regions of the universe we will never be able to observe or measure, which further limits our ability to define a complete picture of its direction. So when we say we may never fully know our final direction, it reflects a deeper reality. The universe is still unfolding, and our understanding of it is incomplete. We are part of a system that is still in motion, still changing, and still revealing new layers of structure and behavior. No matter how advanced our science becomes, there may always be aspects of cosmic direction that remain beyond our reach, not because of lack of effort, but because of the vastness and complexity of reality itself. When we look at the motion of Earth today, it can feel like everything is perfectly stable and predictable. The planet spins, orbits the sun, and follows a consistent path that has remained unchanged for what seems like an extremely long time. From a human perspective, this stability creates the impression that Earth's journey through space is fixed and unchanging. However, when we zoom out to cosmic timescales, this sense of stability begins to disappear. Earth's path is determined by a balance of gravitational forces, mainly from the Sun but also influenced by other planets, passing objects, and the broader structure of the solar system. This balance creates what we experience as a smooth and regular orbit, but this balance is not absolutely permanent. It is a dynamic system, meaning it depends on conditions that can change over time. One important factor is that the Sun itself is not static. As it moves through the Milky Way, it passes through different regions of space with varying gravitational influences. These regions are not identical. Some contain more stars, some have dense gas clouds, and others are influenced by large-scale gravitational structures. As the solar system moves through these environments, subtle changes can occur in how gravitational forces interact with Earth's orbit. Another factor is the presence of other objects within the solar system. Planets, asteroids, and comets all exert small gravitational effects on one another. While these influences are often minor on short timescales, they can accumulate over millions or billions of years. Even small changes in position or velocity can slowly alter orbital patterns in ways that are not immediately noticeable but become significant over very long periods. There is also the concept of orbital resonance and gravitational interaction between planets. In some cases, these interactions can create long-term shifts in stability. Orbits that appear perfectly regular over short periods can gradually evolve due to repeated gravitational influences. This does not mean Earth's orbit is about to change dramatically, but it does mean that its path is part of a system that is always adjusting, even if the adjustments are extremely slow. Beyond the solar system, larger cosmic events can also play a role over vast timescales. The Milky Way itself may experience gravitational interactions with nearby galaxies. These interactions can subtly influence the motion of stars and star systems within it. Since Earth is part of the solar system, and the solar system is part of the galaxy any large-scale change in the galaxy can indirectly affect our long-term cosmic environment. It is important to understand that not stable forever does not mean sudden chaos or immediate danger. Instead, it refers to the idea that nothing in space remains in a perfectly fixed state indefinitely. Stability in the universe is always temporary and depends on a balance of forces that can evolve over time. Even the most regular systems are still part of a larger dynamic structure. Earth feels like a constant and reliable platform for life. Days follow nights, seasons repeat, and the orbit appears unchanged within a human lifetime. But this consistency exists within a much larger framework of slow transformation. On a scale of millions or billions of years, the conditions that maintain Earth's current path may gradually shift as the solar system evolves. So when we say Earth's path up is not stable forever, it means that the orbit we experience today is part of a living system of motion. It is stable enough for life to exist, but it is not frozen in place. It is continuously shaped by gravitational interactions, cosmic environments, and long-term changes in the structure of space itself. When you look up at the night sky, it often feels like you are staring at something permanent. The stars here fixed in a place, arranged in patterns that stay the same night after night. This creates a strong illusion that the sky is stable and unchanging, almost like a painted dome above Earth. But this sense of stillness is only because of how short our human lifespan is compared to the enormous timescales of the universe. In reality, every single point of light you see in the night sky is in motion. The stars are not attached to a fixed background. Each star is an individual object moving through space held within the structure of the Milky Way galaxy. They do not remain in the same positions forever. Instead, they travel in different directions at different speeds, following paths shaped by gravity and the overall motion of the galaxy. Some stars orbit the center of the Milky Way, while others move in more complex or tilted paths, depending on their location and gravitational influences. Even the patterns we recognize, like constellations, are slowly changing over time. The shapes we see today are temporary arrangements. Over long periods, the relative positions of stars shift, meaning that the familiar outlines we associate with constellations will eventually become distorted. If someone could observe the sky across hundreds of thousands or millions of years, they would see these patterns gradually transform, breaking apart, and reforming into completely different shapes. One reason this motion is not obvious to us is because the distances between stars are so vast. Even though stars are moving at extremely high speeds, often tens or even hundreds of kilometers per second. Their positions change very slowly from our point of view. It takes thousands of years for noticeable shifts to occur in the night sky. Because human history is so short in comparison, we perceive the stars as fixed points rather than dynamic objects in motion. Another important factor is that we are also moving along with the stars. The entire solar system is traveling through the Milky Way, so our perspective changes along with everything around us. This shared motion makes it harder to detect changes in the positions of stars in real time. We are not standing still watching moving objects. We are moving alongside them within the same larger system. The stars themselves are not identical in behavior. Some are relatively stable and long-lived, while others are more active and dynamic, undergoing changes such as expansion, contraction, or even explosive events like supernovae at the end of their life cycles. These processes further contribute to the idea that the night sky is not static, but constantly evolving, even if those changes are not immediately visible to the human eye. In addition to individual star movement, the entire Milky Way galaxy also has internal rotation. The galaxy itself spins, meaning that stars closer to the center move at different speeds compared to those farther out. This differential rotation slowly reshapes the structure of the galaxy over time, adding another layer of motion to everything we observe in the night sky. There is also the fact that light itself takes time to travel. When we look at a star, we are not seeing it as it is right now, but as it was when the light left it. Some of the stars we see may no longer even exist in their current form. Their light is still traveling through space, reaching us after thousands or even millions of years. This means the night sky is not only moving, but also showing us a layered history of motion across time. So when we say everything you see in the night sky is moving too, it means that nothing above us is truly fixed or permanent. The stars are not static decorations in the sky. They are active, traveling objects participating in the ongoing motion of the galaxy. The night sky is not a frozen image. It is a living system in constant change, unfolding slowly on a scale far beyond human perception. When we think about life on Earth, it often feels like we are living on a stable stage. The ground beneath us feels fixed, the sky above appears unchanged, and daily life gives the impression of permanence. But this feeling of stability only exists because we are experiencing reality from a very limited scale of time and perception. On a much larger scale, everything we are part of is in motion, and that motion never stops. We are not standing outside the universe observing it, we are inside it, carried along within a continuous journey that stretches across space and time. Earth itself is not a stationary platform. It is constantly moving through space, along with the solar system, which is traveling through the Milky Way galaxy. At the same time, the galaxy is also moving through the larger structure of the universe. This means that every moment of our lives is happening inside multiple layers of motion at once. We are not just living on a planet. We are living inside a moving system that is part of an even larger moving system. What makes this idea difficult to notice is that all of these movements happen smoothly and consistently. There is no sudden shaking or visible sign that we are traveling through space at extremely high speeds. This is because everything around us shares the same motion. The air, the ground, the oceans, and even our bodies are all moving together as part of the same system. When everything moves together at the same rate, motion becomes invisible to our senses. The journey we are part of is not random or chaotic. It follows patterns shaped by gravity, cosmic expansion, and the large-scale structure of the universe. These forces guide the movement of planets, stars, and galaxies in ways that unfold over extremely long periods of time. Even though we cannot feel these forces directly, they determine the path we are on and influence the structure of everything around us. Another important aspect of this cosmic journey is time. The universe does not move in a simple, repetitive cycle from our perspective. Instead, it evolves. Galaxies form, interact, and slowly change shape. Stars are born, live their lives, and eventually fade or explode. Entire systems develop over billions of years. This means that the journey we are inside is not just movement through space, but also movement through time, where everything is constantly changing and evolving. Life feels like a sequence of personal moments, days, years, and experiences. But beneath that personal timeline, we are part of a much larger timeline that extends far beyond human history. Our entire existence is a small part of a cosmic process that has been unfolding long before Earth formed and will continue long after we are gone. This larger process is the true journey we are inside. Even the idea of staying in one place does not fully apply to us. There is no moment in which we are truly stationary in an absolute sense. Every second, Earth moves, the solar system moves, the galaxies moves, and space itself expands. We are always being carried forward by these combined motions, whether we are aware of them or not. Seeing ourselves as fixed observers, watching a universe outside of us, we begin to see that we are participants in a system that is already in motion. We are not separate from the journey. We are part of it. Every breath, every thought, and every moment of life happens within this ongoing movement of the cosmos. So when we say we are inside a constant cosmic journey, it means that life is not happening on a still surface, but within a dynamic system that is always moving, always evolving, and always unfolding. There is no pause in this journey, no moment of true stillness. Everything is part of a continuous flow that stretches far beyond what we can directly perceive. Everything we have explored so far, a deeper realization begins to form. The question, where are we, sounds simple, but it is actually incomplete. It assumes that there is a fixed position we can identify and hold on to. It suggests that the universe has a stable map with clear locations and permanent coordinates. But once we understand that everything is in motion, Earth, the solar system, the galaxy, and even space itself, the idea of a fixed where becomes less meaningful. In reality, we are never in one unchanging place. Every moment our position is shifting. Earth rotates, orbits, and travels through space. The solar system moves through the Milky Way. The galaxy drifts through the universe. At the same time, space itself expands and reshapes the distances between everything. Because of this constant movement, our location is always part of a larger process rather than a fixed point. We are not standing somewhere permanent. We are always transitioning through something ongoing. This is why the question shifts naturally from where are we to where are we going. Motion implies direction, even if that direction is complex, layered, or not fully understood. The universe is not a static arrangement of objects. It is a system of continuous movement. Everything that exists is part of trajectories shaped by gravity, expansion, and large-scale cosmic structure. So instead of focusing on a single position in space, it becomes more meaningful to think about the paths we are part of. But even this question is not simple. The direction we are moving in is not like a straight road with a visible endpoint. It is not a journey with a clearly marked destination. The path of Earth, the solar system, and the galaxy is influenced by many overlapping factors that operate over enormous scales of time and distance. These include gravitational interactions with nearby galaxies, the structure of the cosmic web, and the ongoing expansion of space itself. All of these influences combine to shape motion in ways that are gradual, complex, and still not fully understood. Another important point is that going somewhere in the universe does not always mean approaching a single final location. In many cases, it means participating in continuous change. Galaxies move, interact, and evolve. Stars are born and die. space expands and stretches. Even if there is no final destination in a traditional sense, there is still direction in the sense of ongoing transformation. The universe is not static enough for any part of it to remain unchanged or truly settled. It is difficult to perceive this ongoing movement as a direction. We are too close to the system to see its full structure. It is similar to being inside a vast river with no view of its full shape. From inside, we only experience local motion, but from a wider perspective, the flow has a clear structure and direction, shaped by forces far beyond our immediate awareness. In the same way, our cosmic journey is real, but its full direction is not something we can easily observe from within. This leads to a more profound understanding. We are not just asking a question about space, but about existence itself. Where are we going? Is not only about physical movement, it is also about how the universe evolves over time, how structures form and change, and how everything participates in a larger unfolding process. The answer is not a single point or destination, but an ongoing transformation that never fully stops. So the real meaning of this final idea is that existence is not defined by a fixed position. It is defined by motion, change, and continuous progression. We are part of something that is always moving forward in a cosmic sense, even if the exact direction is complex and difficult to fully describe. In that way, the question itself changes its meaning. It is no longer about finding a place, but about understanding a journey that is already in motion and always continuing. So after everything we've explored, one truth becomes impossible to ignore. We are not fixed. We are not still. We are part of a universe that is constantly moving, shifting, and expanding in directions we cannot fully see or measure. Earth is not just a planet sitting in space. It is a traveler, carried through a vast cosmic journey along with the sun, the galaxy, and everything we know. And maybe the most powerful realization is this. We are asking, where are we headed, while already being carried somewhere at this very moment, not by choice, but by the design of the cosmos itself. So the question isn't just about direction anymore. It's about understanding the journey we are already on,